Hey, welcome back to this wonderful session on quantitative analysis. We are starting with the very first chapter, which is Fundamentals of Probability. It is going to be an interesting session. I'm going to use lots of diagrams, lot of visual representation so that you understand the basics of probabilities in the best possible manner. Okay, so let's start. What are we learning today? We're gonna be looking at the very basics of probability, which is absolutely needed before we go ahead and look at the learning objectives. Then we're gonna be looking at few rules of probability in this particular video. We're gonna be talking about the joint probability, the union of the probabilities, mutually exclusive events, conditional probability, this is very important, the unconditional probability, and finally total probability rule. Now only these things I'm covering in this video, so almost like 60 to 70% of the entire chapter I'm covering in this particular video. The other topics, that is independent events, conditional independent events, and the Bayes rule, we're going to be covering that in the next video that I will upload. Okay, so make sure that you subscribe to our channel. We're going to be putting lots of videos on our YouTube channel. I'm also mentioning a link of our Telegram channel. Make sure that you join that as well. Okay, let's start with the very basics. What is probability? Probability, it measures the chance or the likelihood of any event happening. So basically what we are saying is that with the help of probability, you can actually quantify, you can measure the chances of any event that would happen. Banks, they are very much interested in knowing the chance or the likelihood of their borrowers defaulting on their loans. So banks, they use probability to identify the amount of losses on their portfolio. Another example is the insurance companies. They also use probability so that they can identify what will be the claims on their policies. All right, so they have the probability as a quantification tool. Probability is used a lot in the insurance industry as well. Let's take a final example. Do you want to know what is the likelihood that you will pass the FRM exam? Well, with the help of probability, you can find that. Okay, so probability, I mean, it's everywhere. Whatever event that is happening, okay, whatever the outcome that we have, we are interested in knowing the chance of happening that event. Now there are two important properties of probability, and we should know this. Okay, it's a must know for the exam. The very first one is the sum of probabilities of all outcomes will equal 1. Now what do I mean by that is that when you add the probabilities of all the outcomes, okay, that would equal 1. It's not going to be less than 1, it's not going to be greater than 1. The second property is the probability of outcomes will be between 0 and 1, including both. Now what does this mean? For example, if I find the probability or the chance of anything happening, okay, let's say that I throw a coin and I want to know that what will be the probability of the coin landing heads. Okay, so the answer would be between 0 and 1. Okay, so I've drawn this picture here so that you understand the probability will always be between 0 and 1. We can take any example of probability and the answer would always be between 0 and 1. I can convert the 0 and 1 to percentages as well, so I can write as 0% and 1 as 100%. So anytime the probability will not exceed 0 and 1. You cannot have a probability of, let's say, 1.2, 1.5. It will always be maximum at 1, including this thing as well. So, and it cannot be less than 0 as well. You cannot have a probability less than 0. Okay, so it has to be between this range. That's what this rule or this property means. Alright, now one important thing is that if I say that the probability of something is 0, that means it is an impossible event. Okay, to give you an example, let's say that if you toss a coin, you can only have heads or tails, right? You cannot have heads and tails both at the same time. So the probability of having heads and tails both at the same time is an impossible event. and that is why it has a probability of 0. To give you another example of an impossible event, let's say that you are giving an exam and the probability of you passing and failing both is 0, right? Because you cannot pass and fail at the same time. So that's an impossible event. So that has a probability of 0. On the other hand, if I say that if you're tossing a coin and you can get either heads or tails, but either of these two outcomes will happen, so that will have a probability of 1, because either of these things will definitely happen no matter what. So that is known as a certain event. So if some event has a probability of 1, we call it as a certain event. Now there's a formula to calculate probability, and the formula is very simple. It says the number of favorable outcomes divided by the number of possible outcomes. Okay, let's take 3 examples here so that we understand this particular formula well, and we also confirm that do these properties actually hold in reality. Okay, starting with the first example, suppose that you toss a coin. What are the possible outcomes? What can happen? Either you will get heads or you will get tails. Only 2 possible outcomes. There's nothing else, right? So you want to find the probability of getting heads. Okay, so what is that? The number of possible outcomes in the denominator, there are only 2 possible outcomes, so we write it as 2. The number of favorable outcomes, you want head, right? You want to find the probability of head, so I will write it as 1. There's only one way I can get heads on tossing a coin, so I write here as 1, and if I do this calculation I get as 0.5. so 0.5 is 50%. So now you can confirm that the answer that we got here is between 0 and 1, somewhere here 0.5, and in percentages it is 50%. Okay, similarly I can calculate the probability of getting a tails. It is again only 2 possible outcomes, right? The number of possible outcomes in the denominator, and only one way I can get tails, right? So I've written as 1, and again it's 0.5. okay, same 50%. Moving on to the next example, suppose that a candidate has enrolled for the exam and he wants to know the probability of passing on the exam. Okay, how many possible outcomes are there here? Only 2 possible outcomes. Either the candidate will pass or the candidate will fail. No other outcome at all, right? So only 2 possible outcomes. Okay, and the candidate wants to know the probability of passing. So only one possible way in the candidate can pass, right? So again it's 0.5, and the probability of failing on the exam is also going to be 0.5. Just we follow the calculation and we get here. Now if I roll a die or a dice, then what are the possible outcomes? I will either have 1, 2, 3, 4, 5 or a 6, right? Any of these 6 possible outcomes I can get, right? So if I want to know, let's say, the probability of getting a 6, so if I roll a die and if I want to know the probability of getting a 6, as I said, the possible outcomes, number of possible outcomes in the denominator is going to be 6. Okay, there are only 6 possible outcomes, and the number of favorable outcome is only 1. There's only 1 6 here, right? So I write it as 1/6, and that is equal to 0.166, or in percentage it is 16.6%. So now in all these 3 examples we have seen that the probability, they always are between 0 to 1. So okay, so this confirms our second rule of probability, which is the outcomes will be between 0 and 1, including both. And the other thing is that when you add these probabilities, okay, if you add 0.5, that is equal to 1. If you add the passing and failing is also equal to 1, and if you add all these, then if you want to find probability of getting a 1, getting a 2, if you add all these things, it will be equal to 1 as well. Okay, so this also confirms that the second rule, which is the sum of all probabilities, will equal 1. Okay, alright, so moving on, we're going to be talking about a lot of types of probability. Okay, what are the different types of probabilities that we have? and I'm directly moving to learning objective 12 EF. Okay, I'm not moving to B because I feel that to understand the concept in B and C, we need to understand these things first. Okay, so the very first type of probability is joint probability. Now joint probability is something, it's also sometimes referred to as multiplication rule, and all it means is that event A and B both occur together. Okay, so when we have two events, that is A and B, and when they both will occur together, that is when we call it as a joint probability. Now notation wise, we can write joint probability as probability of A and B. We can also write as probability of A, B, and also we can say that probability of A, the symbol here is known as intersection. Okay, so we can say that probability of A intersection B, and all these three mean the same thing, that we have to find the joint probability. Okay, now it's known as the multiplication rule. So what do? We just multiply both these events. Okay, let's see how it looks on the Venn diagram so that you can understand this thing visually. So let's say we have this circle here, this is event A, and the circle on the right, that is event B. Now what we are interested in finding is the joint probability of A and B together. Okay, they both occur together. Now to give you an example, let's say that you have invested in IBM stock, and at the same time you've also purchased Apple stock. Okay, and you want to find the probability that both of them will go up tomorrow. So essentially what you're doing is that you are interested in finding the joint probability of these two stocks going up together. Okay, so what do? We just take the probabilities of these stock going together and we simply multiply that. Another example is, let's say that, okay, so you are interested in finding the probability that both the inflation and recession will happen at the same time. Okay, so what is the probability of these two events? So what do? We simply multiply to find the joint probability. Okay, now on the Venn diagram here, this rectangle is our sample space, something that we have already seen in the last slides. In this diagram here, the intersection at this point, this is the joint probability of both these events. Where they are joining together, that is the joint probability. Okay, so hopefully you get the idea, and that is why we go ahead and we multiply these two probabilities. So now you can see for yourself that the place where both these events intersect, and that is why we have this intersection symbol, that is our joint probability. Okay, let's take an example to understand that. So suppose we have the probability of a credit rating downgrade of a particular bond, and that probability is 40%, and the probability of the same bond defaulting is 50%. So we have both these probabilities with us, and we want to find what is the joint probability of a rating downgrade as well as the bond default. And you can understand we are looking for joint probability with this word and. Okay, so when you see and between the probabilities, you simply go ahead and you multiply it. So if this is credit rating downgrade probability and this is the probability of a bond default, we just find the place where they intersect, and we can find this by multiplying these two probabilities. Okay, so here what we do is that we simply go ahead and we multiply the probability of rating, that is 40%, multiplied by the probability of default, which is 50%, and the joint probability we have is 20%. Okay, so this is the joint probability of a rating downgrade as well as bond defaulting at the same time. Hopefully you're clear with the joint probability. Now the other thing that we have here is mutually exclusive events. We say that some event is mutually exclusive events when both the events A and B cannot happen together. Okay, the main thing here is it can't happen together at the same time. To give you an example about mutually exclusive events, let's say that you want to find the probability of getting a heads and tails on the same toss of a coin. Is it possible? No, because they are mutually exclusive events. Similarly, passing on the exam as well as failing on the exam, they are mutually exclusive events. They cannot happen at the same time. So let's say we have event A here and event B here, and as we can see from the Venn diagram, they cannot happen at the same time. So the joint probability of A and B, okay, the joint probability of AB when the events are mutually exclusive events would be 0. Now in this particular example, if we had this information that these two events, the rating downgrade of a bond and probability of default, if they are mutually exclusive, the joint probability would simply be 0 because they will not intersect together, as we can see here. So hopefully you get the idea about the joint probability and the mutually exclusive events. Moving on, now we are talking about the union and the addition rule. Okay, so this union and the addition rule, it's something that when we are interested in finding the probability of either event A happens or event B happens. So sometimes we are interested to find, let's say that either one of my stocks goes up or the second stock that I have, it goes up, right? So sometimes we are interested in either one thing goes up or second thing goes up, either the inflation will happen or either recession will happen, right? So sometimes we are interested in finding these kind of probabilities, right? So what do? We simply add these probabilities. Let's just have a look at the notation here. So union or the addition rule is written as probability of A or B. As I said, if you see or, you can understand that it's an addition rule. And also we have something as probability of A union. The symbol that you see here, it's known as union. A union B is equal to probability of A plus the probability of B. This is the addition rule minus the joint probability here. Now don't get scared with the formula here. I'm going to give you a visual look. Okay, so here we have the sample space. This is a Venn diagram. So let's say that this is event A and this is event B. Okay, so probably this is something an inflation and this B is a recession. Okay. So as a researcher, I am interested to find the probability that either inflation will happen in the economy or a recession will happen. Okay, so when I'm interested to find either or probability, I simply add these things. But what is happening? I'm adding this entire A circle here. Okay, I'm adding this thing here, but at the same time I am also adding this B, right? Adding these two probabilities. So I'm also adding this B. So now as you can see, this intersection here or the joint probability here, this is simply the joint probability, right? I am adding this thing twice. I've already added in red, then again in blue color I have also added it once again. So to remove this double counting where I'm counting it twice, I simply remove this joint probability. So hopefully you get the idea. Let's take a simple example to understand. So we've been working with the credit rating downgrade of a particular bond, and that probability, as we have seen, is 40%, and we're also given the probability of default, which is 50%. All right, so what is the probability of either a rating downgrade or a bond default? Okay, the same question that we have been working so far, and we are interested now that either A happens or B happens. Either a rating downgrade of a bond happens or the bond defaults. Either of these two events. So we simply use this particular formula, which is I add both these probabilities, and while adding these up, we have to remove the extra or the double counting effect of the joint probability or the intersection here, right? So the answer is 40% plus the probability of B is 50% minus the joint probabilities. Now joint probability is something that we have already calculated in the previous slide. So the joint probability, as I said, it's known as the multiplication rule. Where they intersect, we simply multiply. So the A probability is 40% times 50%, that is 20%, right? So this is the probability. We simply remove this 20% and we have an answer 90 minus 20%, and that is 70% is the probability that either A will happen or B will happen. Okay, simple enough. No need to remember the formula, just have a look at the Venn diagram and you can see for yourself where these formulas are coming from. Okay, now for mutually exclusive events, if event A and B are mutually exclusive, they cannot happen together. We have here A and B. Now if both these events are mutually exclusive, then there is no intersection between them, there is no joint probability. Then the addition rule simplifies to only probability of A plus probability of B. There is no intersection, so no need to subtract this thing. All right, simple. Now we are talking to the major important thing, and that is known as the conditional probability. Okay, now conditional probability in FRM level 2, you will come across this thing multiple times. Okay, so to give you an example of a conditional probability, we are saying that, let's say that one event has already happened and we are interested in finding what is the probability of the other event. So let's say a very simple example can be is that, let's say inflation has already happened in the economy. Now what is the probability of a recession? So what we are saying is that the probability of event A happening given the probability of event B has already occurred. Another way to state that is that I've invested in 2 stocks, one stock has already gone up. So now what is the probability of other also going up? So that means I'm saying that conditional probability. Okay, so now notation wise, conditional probability looks something like this. The probability of A, this vertical bar, is known as given that B has already occurred. So the probability of finding a recession given inflation has already occurred. So we already know that B has already occurred, and to find this probability, what we do is that we simply take the joint probability of both the events happening divided by the probability of B. I'm going to give you a very simple example. Let's have a look here and we understand where this formula is coming from. Don't need to remember that. So this is again our sample space, and this is probability of A, this is the probability of B, right? Now in conditional probability, we are already given the information that B has already occurred. So we know that inflation has already occurred. It's there in the market, right? So our sample space, it reduces to a new sample space, which is this right circle. Okay, so we have this circle. Now this becomes our new sample space. All right, so hopefully you get the idea that the sample space is now reduced to this B, and that is why in this conditional probability formula we have the denominator as the new sample space, which is the probability of B. Now you want to calculate the probability of A. Now where do you see in this entire sample space, where do you see A? So this is the only place where you see probability of A as well, which is the joint probability. So that is why we have this thing in the numerator and this thing in the denominator. So no need to remember this formula. All look at this particular Venn diagram. When we are working with conditional probability, our sample space reduces to a new sample space, and this is the area we see the probability of A, which is the joint probability. So hopefully you can now remember this formula in a better way. Let's take a simple example. So suppose the probability of rating downgrade is 40%. The same example, the probability of default is 50%. And now we are here and we are trying to find the conditional probability of a bond default given the rating has been already downgraded. Okay, so this thing that you see here, given the rating has already been downgraded, so the sample space is now reduced. So I'll write it again. So the probability of a bond defaulting given that rating has been downgraded. So we need to find the conditional probability of bond defaulting given that the rating has already occurred. So we now know that the sample space is the probability of this event, that the rating has downgraded, which is 40%, that is 0.4, and the joint probability of these two events, that is 0.4, which is 40%, times 50% is 0.2, that is 20%. So 0.2. So we have the conditional probability as 0.5, which is 50%. So this 50% is the probability that the bond will default given that the rating has been downgraded of this particular bond. Now I want you to note one thing here, that if on the exam I'm given this conditional probability of A given B, if I'm already provided this thing in the information here, and if I'm asked to calculate this joint probability, I can do that, right? I can simply take the multiplication of these two things, the probability of A given B times the probability of B, and I will have my joint probability as the answer. All right, quite simple. So this is another formula that you will see on your textbook, and so don't get confused. It is just this thing here, okay? Just a multiplication of these things, the pure algebra thing. Now when we're talking about probabilities, it's important that we revise what we have learned so far. Okay, so we have talked about 4 things so far. The first thing is the joint probability, which is on the Venn diagram. You can see this is the joint probability where both the events A and B, they intersect each other. So simply we are multiplying both these events. That's what we see here. Also it is known as the multiplication rule. So probability of A and B, probability of AB, and probability of A intersection B is the multiplication of both the probabilities. Simple, right? The union is also known as the addition rule. We simply add these probabilities because we want to find what is the probability of A or B. Okay, and also if you see, this is the union symbol, so we just add the probabilities and we subtract this double counting what we have done, because if I add the probability of A in red and if I also add the probability in B, so I have added twice, right? So I need to remove this joint probability here, which is probability of A and B, okay? Because I'm counting it twice, I need to remove it once. Clear with this, right? Then we talked about conditional probability. Now conditional is the probability of event A given this bar represents given B has already occurred. Now this has already occurred, so we have our new sample space in red. We do not have anything beyond this red. Okay, so this new sample space, it comes in the denominator, and the only place where A is there is in this black line, which is the intersection of A and B, which is the joint probability here. So that is why we have this in the numerator, and we divide this by the reduced sample space here. And finally we talked about mutually exclusive events where both the events A and B, they do not intersect each other. So when it comes to joint probability, the probability of A and B, if they are mutually exclusive, joint probability would be 0. The addition rule, we just remove this thing, because even in conditional probability, if there is a mutual exclusive events, the conditional probability would also be 0, because 0 divided by anything would be 0. Okay, so conditional probability would also be 0 if the events are mutually exclusive events. Now so far we have not talked about the unconditional probability, right? Unconditional probability is simple probability. Let's say that a probability of getting a heads on a coin toss is 50%. So that 50% is the plain probability, right? So that is known as unconditional, without any conditions. So the individual probabilities that we have, so for example, probability of passing on the exam is 50%, right? So this simple probability is known as the unconditional probability. Okay, we are just naming it here. Okay, that is unconditional. Otherwise, when we say that the probability of a bond defaulting is, let's say, 40%, so that 40% is just the unconditional probability, and conditional probability is something that we can calculate given some conditions here. Something has already occurred. So this is the only difference that we want to know. And before I end this video, let's talk about total probability rule. Okay, it's a very simple rule. Once again, let's look at this thing here. This is rectangle is our sample space. We have two mutually exclusive events, which is event A and event B. Only these two events in our entire sample space, and both these events are mutually exclusive. As you can see, they do not overlap each other. Now, for example, let's say that we have another event here, and I call this event as C. So this rectangle that you see here, this is a new event C, and we are interested in finding the probability of this rectangle C, okay, this event C. So how do we do that? Well, just have a look on the Venn diagram here. The unconditional probability of this C is the intersection between A and C. As you can see, there's an overlap here. Okay, so this is the intersection between A and C. So I can write as the total probability rule the joint probability, or the intersection between A and C, plus this intersection between B and C. Okay, it's intersection between, so the intersection between B and C. So effectively, if I want to find the probability of this event C, I can just have the joint probability of A and C plus the joint probability of B and C. If I have this information with me, I can find the probability of C. And that's exactly what is meant by total probability rules. Okay, so we are just summing these probabilities. We are just calculating the total of this rectangle, and we can find the unconditional probability of our new event, which is C. Alright, pretty simple, right? And when you see your textbook, they have given a scary looking formula. All they are saying is that, let's say that if we are given the conditional probability of C given A, when we have a conditional probability, this whatever there is there after given, that becomes our denominator, which is A in our case, and over here we have the joint probability of AC, okay, event A and event C. Now I can replace this thing with this here, which is the probability of C given A times the probability of A. And similarly, so given the conditional probability of C given B, then this probability of B in the denominator, and probability, the joint probability of B and event C. So I can replace this thing with this probability of C given B times the probability of B. So don't get scared when you look at the formula in the textbook. All it says is that the total probability can be calculated when we are given the joint probabilities of these two events. Okay, so if I have a joint probability already given in the exam or in the question, then I can find the unconditional probability of the new event, which is C. And also, if I'm given the conditional probabilities, as in this case here, I can again find the unconditional probability of C given this information. Okay, so that's what the total probability rule is all about. you have a look at the diagram, and you can simply, by looking at it, you can say that it's just the intersection. You add up these intersections, and that's it. That's the total probability rule. With this final rule, I've already covered approximately 60 to 70% of the chapter. Now in the next video, as I said, we're going to be talking about independent events, conditionally independent events, and the most important rule, which is the Bayes rule. Now the Bayes rule is something that there is a high probability, there is a high chances that might show up on your exam day. Okay, and I'm going to give you a tip as to how to solve it effectively on the exam with less minutes that you have. Alright, so we'll meet in the next video. Thank you so much for your time and have a great day ahead. Thank you.